from the book The Field. We're going to talk about warp drives right now. Okay, we're on page 230. Then Hale thought of turning the whole project inside out, following up on a notion first mooted by general relativity theorist Miguel Alcubierre of the University of Wales. Alcubierre, I'm not sure I'm pronouncing his name correctly, had tried to determine whether warp drives as described in Star Trek really were possible. Suppose you ignore quantum theory and look upon this as a problem of general relativity. Instead of invoking Niels Bohr, you invoke Albert Einstein. What if you tried modifying the space-time metric? If you use the curved space-time of Einstein, you treat the vacuum as a medium that could be polarized. I hear that word a lot, polarized, polarizing space. This is very important. You do a little vacuum engineering, as Nobel Prize laureate Sung Deo Lee called it. Under this interpretation, the bending of a light ray, say near a massive body, is caused by a variation in the refractive index of the vacuum near that mass. The propagation of light defines the space-time metric. When you might be able to do, or what you might be able to do, is decrease the refractive index of the zero-point field, which would then increase the speed of light. If you modify space-time to an extreme degree, the speed of light is greatly increased. Mass then decreases and energy bond strength increases. Features that theoretically would make interstellar travel possible. What you do is to distort and expand space-time behind the spaceship, contract space-time in front of it, and then surf along it, on it, faster than the speed of light. In other words, you restructure general relativity as an engineer would. If you could successfully do this, you could make a spaceship travel at 10 times the speed of light, which would be apparent to people on Earth, but not to the astronauts inside. You'd finally have a Star Trek warp drive. And this is page 221. And please read this book for yourself if it interests you. It's called The Field. It's a very good book. It's very helpful if you're interested in learning about zero-point energy and vacuum energy and basically the history of relating to energy and studying energy for the use of travel throughout space. It's been studied and documented, and it's been worked on and experimented with for a very long time. And you can also study John Searle, Ralph Ring, Otis T. Carr, Thomas Townsend Brown, among many others.